Hi friends, so far we have covered two topics in Java at JVM architecture. So class loader we have discussed in part 1 of the video and JVM memory we have discussed in part 2 of the video. So friends, if you have not watched that video, please watch it because without watching that video, this video will be meaningless to you. So I have given link of both the videos in the description box. Also, if you are new to the channel, please do not forget to subscribe my channel so that you never miss an update on my upcoming videos. So let's start today's topic. So today we are going to see the third part of the video, execution engine, along with other modules like native method interface, native method libraries, code cache, JIT compiler. So now let's start with interpreter, which is the first component of execution engine. So after class loading and memory setup, the JVM needs to execute the code. So the interpreter does this by reading the Java bytecode and executing it line by line. Now let's see how an interpreter works. So Java source code is compiled into bytecode. The interpreter reads one bytecode instruction and it converts it to machine code. It executes it immediately and then it moves to the next instruction. So JVM bytecode with the help of JNI Java Native Interface is getting converted into machine code. Now let's see below points. It reads bytecode line by line. This we have seen already. So second point is it executes instruction one at a time. What does it mean? The interpreter does not convert the whole method at once. It executes one instruction at a time again and again. That's why it's called interpretation, not compilation. So next, it is quick to start but slower for repeated code. What does it mean? The interpreter is quick to start but it becomes slow when the same code runs again and again. Next, it is less efficient for frequently run code. What does it mean? The interpreter is less efficient when the same code is executed frequently. Now let's understand the JIT compiler, which is also called just-in-time compiler, which is part of JVM execution engine. As we saw earlier, the interpreter executes bytecode line by line, which is slow for frequently running code. So to improve performance, JVM uses JIT compiler. So JIT compiler improves performance by compiling frequently used bytecode into fast native machine. So the hot code, which is frequently executed with the help of JIT compiler, is moved to native code, and this native code is then later stored in the code cache, that is native memory. So now let's see below features of working of JIT compiler. So first is it speeds up the frequently run code. Next, it compiles only hot code at runtime. What does hot code means? Hot code means frequently executed bytecode. So it compiles only frequently executed bytecode at runtime. So this hot code is sent to Git compiler. So Git compiler converts this bytecode into native machine code. This compilation happens at runtime, that's why it's called just in time. So after compilation, the native machine code is stored in code cache, native memory. So code cache is a part of native memory. JVM directly executes this native code next time. No interpretation, no recompilation. So this is what this line means, stored compiled native code in code cache. So friends, till now if you enjoy watching my video, please do not forget to subscribe my channel. So now let's move to next topic. Now let's see what is code cache. So code cache stores JIT compiled native code from frequently executed bytecode. So frequently executed bytecode with the help of JIT compiler is moved into code cache native memory area. So now let's see what are the features of working of code cache. So it stores frequently compiled native machine code. So where does code cache exist? It exists in native memory outside Java heap. It allows faster execution of hot code. This we have already seen. Next, it improves repeat performance a lot. JVM avoids reinterpreting code by reusing compiled machine code from code cache. What does it mean? So JVM runs compiled code from code cache instead of interpreting it again. So this is all about code cache. Now let's see what is garbage collection GC. Garbage collector automatically frees up memory by deleting objects that are no longer needed. So this is a diagram of JVM memory where we can see unused objects are being deleted by garbage collection. So how does it delete the object? It finds unused objects in the heap. So how garbage collection find these unused objects? So suppose the references which are set to null, like for example, suppose we have string s is equal to new string of Java and that s is pointing to null. So since s is pointing to null, the object is been garbagely collected. So second, when any method execution completes, it is eligible for garbage collection. So it deletes those unused objects to free up memory. It reclaims memory so JVM can reuse it. What does it means? It means the JVM frees the heap space used by unreachable objects so that space can be reused for creating the objects, and which helps to prevent memory leaks. So this is all about garbage collection. Now let's move to next topic. Let's see Java native interface now. So JNI allows Java applications to interact with native code written in languages like C or C++. So JNI acts as a bridge between Java code and native code. So this JNI, it acts as a bridge between Java and the native code. So what are the features of JNI? It invokes native functions from Java, example C or C++. It calls Java methods from native code. It passes data between Java code and native code. It accesses platform specific features and libraries. So that's all about JNI. Now let's see native method libraries. So native method libraries are collections of native code written in languages like C or C++ that can be loaded into Java applications for executing platform specific functions. So Java program with the help of JNI goes to native method library. Now let's see the features of native method library. First is it extends functionality beyond Java. What does it mean? It means Java uses native code to do extra work that Java alone cannot handle. Next, it accesses platform specific resources. What does it mean? It means Java talks to Windows, Linux or Mac operating system features using native code. Next, it improves performance using native code. What does it mean? Native method interface improves performance by allowing Java to execute critical code directly into faster native languages like C and C++. So guys, if you really found this video helpful, please like the video, share the video to your friend circles and subscribe to my channel. I have given complete Java playlist in the description box, and if you have any doubts regarding this video, you can put your doubts in the comment section. So whenever I get free times, I can look into it and solve your queries. Happy learning with Java and see you in the next video.